Good morning. My name is Gideon Polwan, and I'm with my group. We been doing a case study for Proton Satria GTI 1.8. So, this is our content, and this is our car catalog. So, for our overview, dynamic load transfer, accelerating uphill shifts a significant amount of weight from the front to the rear axle. Traction limits power. The vehicle's initial acceleration is limited by tire grip, not just engine power, and inherent design trades off. Any modification, especially to tires or aerodynamics, involves balancing benefits and drawbacks. So this analysis look at a car's performance from several angles, how it handles forces during acceleration, how its gears and suspension work, and the trade-offs of changing its tire. So this for question one, we figure out the load distribution on the axles when the vehicle accelerates from a standing startup at a 4% uphill road at 3.7 miles meter per second square, assuming the CG height is zero point 0.5 meter. So here is the calculation. So for the curb mass is 980 kilogram, the weight of the car itself, and we assume the driver mass is 75 kilogram. So for the total mass is 155 kilogram. So for the total weight, we use WMG formula, which is uh, 1055 times 9.81 equals to 103 at 10,349.6 Newton. So the car is front wheel drive, four wheel drive, so it's heavier at the front when parked. So the static front weight is zero point 0.6, which is from 60%. We assume for the typical four wheel drive, front 60% and rear 40%. So for static front weight, we use zero point 0.6 times 10,349.6 equals to 6,209.8 Newton. And for static rear weight, we use zero point 0.4 times 10,349.6 equals to 4,139.8 Newton. So the third step is find the center of gravity. So the wheelbase, the distance between axles is equal to 2.44 meter, and the distances from the CG to the axles are calculated as C, which is distance from the front axle to CG. So here's the calculation, and we got the answer, which is 1.464 meter. And for the next step is the slope angle. 4% slope angle means for every 100 meters forward, the road rises 4 meters. So slope angle, so we use the basic formula, which is 10, and we get the answer, which is 2.229. And for the next step, we need to find the dynamic axle loads, the main calculation, the main part. There are two forces that try to lift the front of the car during uphill acceleration, which is the slope and the acceleration. So for front axle load, which is WF, uh, the formula subtract the effects of the slope and acceleration from the static front load. So we use W times C times cos minus W times H times sin, and minus M times AX times H. Uh, and then here we got the answer, which is 5,319.9 Newton. And we do the same for the rear axle load. Just change the C to B, and we got the answer, which is 5,021.7 Newton. So for the summary for this calculation, when the car accelerates uphill, weight moves from the front to the rear axle. This happens because going uphill and speeding up both push the car's weight backward. For the Proton Satria 1.8 GDI, accelerating at 3.7 meter per second square up a 4% slope, the front axle carries about 5,320 Newton and the rear axle carries about 5,022 Newton. Macam mana pos iki? Oh, pos.
So hi, my name is Darren Suguna Nelson. So I'm gonna to explain the question two. So the question two is determine the vehicles first until four gear tractive force, and second is traction limited acceleration in the coefficient of fraction is 0.62. So for gear ratio, so first gear is 3.083. For the second gear is 1.947. For the third gear is 1.285. For fourth gear is 0.939. So as we calculate the gear, so we use this formula fx equal to te times ig times if times, so we use a formula fx equal to te times ig times if times lambda f per r. So for the first gear, after we calculate using the formula, we got answer 7,207.4 Newton. For the second gear is 4,855.7 Newton. For the third gear is 3,004.0 Newton. For the fourth gear is 2,195.3 Newton. So for the answer for question 2, for 2I, FWD carburetor weight in M is 980 kilo. Weight distribution is 60% in front. So WF is equal 0.06 times 918 times 9.18 equal to 5,768.3 Newton. So the F max is equal to 0.62 times 5,768.3, and it's equal to 3,576.3 Newton. So we compare the first gear till third gear. First gear is 7,207, is biggest from 3,576. The first gear is slip. The second gear is 400, 4,551, more bigger than 3,566. It slip. So the third gear is 3,004, smallest from 3,576. There is no slip. So maximum acceleration limited by traction A max equal to F max per m equal to 3576.3 divided by 980 equal to 300 point equal to 3.65 meter per second. But if we include a rotational inertial effect, the actual tractive force at high acceleration is lower than the first term we computed. For the traction limit calculation, we don't need inertia because we finding the maximum force the tires can transmit, which is this.